Hello children and welcome to the class today. Children, we have learnt about energy. We have learnt about various forms of energy. Today we are going to understand a very interesting form of energy which is sound. Chapter number 13. We are going to understand its production and characteristics, how it is propagated, what is the working of the human ear, how sound is reflected and absorbed, and how musical sound is created, and what is noise. So children, right now I am talking and you are hearing me. So what am I emitting from my mouth? I am emitting sound which is reaching your ears and you're able to understand the lesson well. So we hear various sounds during the day. We hear chirping of birds, sound of a waterfall, whistling of wind, musical notes of orchestra, sitars that appear pleasing to our eyes and elevate our mood. In fact, there are many sounds in our environment that we don't want to hear. The sound of loudspeakers, the sound of honking cars. So, in this chapter, we are going to understand all of this. First, let's understand how sound is produced. There is a simple experiment which you can do at home also, and from this experiment you will conclude that striking one object with another produces sound. So you take a spoon, take a plate, strike them together, you get sound. Due to vibration in the string and rubbing of one object with another also, you get sound. So children, sound in addition is also produced by membranes in the air column. For instance, when you beat the drum, when you are doing a march pass or you beat the dholak, that membrane vibrates and produces a sound. In a flute or a saxophone, the vibrations of the air column is responsible for also producing sound. And as is evident in this picture, the vocal cords provided in our throats are responsible for producing sound. And this is a special slitted flap-like tissue. What are the vocal cords? They are a flap-like tissue which produce sound. Now let us take a tuning fork and do a simple experiment. Take a tuning fork. A tuning fork is a scientific instrument which is U-shaped with a handle. When it is struck against a rubber hammer, it produces sound. Now bring a light object like a ping pong ball or a table tennis ball close to one of the prongs of the tuning fork. You will observe that the ball is deflected. This shows that sound has energy which causes deflection in the position of the ball. So from all these activities, what do we conclude? That sound is a form of energy which is produced when objects vibrate. It is a form of energy which can induce vibration or it can cause disturbance of objects also. Children, sound essentially travels in waves. How do you prove this? You can prove this by bringing a vibrating tuning fork to a pan of water. You will see that the waves are created in the pan of water. So that proves that the sound has a wave-like nature. Now let's understand the oscillation. What is oscillation? When something moves from its mean position to another position and back, then to another position and then back. This is oscillation. So we understood a few points from this particular experiment. What are they? The maximum distance to which the bob moves from its mean position after being pushed is known as the extreme of the bob. The distance between the mean position to either of the extreme is known as amplitude of the oscillation. The path traveled from mean to the extreme of one side to the extreme of the other side and back to the mean is known as the one complete oscillation. You will find that some time is lapsed during the oscillation. This is known as a time period of oscillation. You can measure the time lapse using a stopwatch. If the number of oscillations divided by the time, it gives the number of oscillations per second, which is also known as the frequency of oscillation. The unit for the frequency of oscillation is known as hertz. So there are basic characteristics of sound. A sound can be loud. A sound can be soft. So what is loudness of sound? It is proportional to the square of the amplitude. To understand more, let us watch a video. Sound has three characteristics: pitch, loudness, and quality. Pitch is a characteristic of sound that enables us to distinguish a shrill sound from a hoarse sound, even though the two sounds have the same loudness. An object that vibrates with a low frequency produces a sound with a low pitch. An object vibrating with a high frequency will produce sound with a higher pitch. Women and children have a shrill voice as compared to men because they have short vocal cords which vibrate with a high frequency. Men, on the other hand, have larger vocal cords which vibrate with a low frequency and thus produce a low-pitched, hoarse sound. Now, children, how is sound propagated? We know that the sound travels in wave. There are simple experiments that tell us how we can understand the propagation of sound. A similar principle applies to the propagation of sound in the medium. Now, sound can travel through air, sound can travel through water also. Now, how does sound reach our ears? Let us understand the structure of the ear to understand propagation of sound inside the ear. The ears help us to hear sound. The ear has three parts: the outer ear, middle ear, and inner ear. The outer ear has a flap-like structure called pinna, which is connected to the ear canal, which has a eardrum at its end. Eardrum is a thin circular membrane. The middle ear has three bones: the hammer, the anvil, and stirrup, whose one side is connected to the eardrum and the other side is connected to the inner ear. The inner ear contains cochlea that is filled with a fluid and has air cells. The auditory nerves send nerve impulses from the ear to the brain. Sound is heard by us in the following way. The human ear can hear sounds having a frequency that lie between 20 Hz and 20,000 Hz. This is called the audible range of the human ear. Inaudible sounds with a frequency less than 20 Hz are called infrasonic sounds. Whales and dolphins produce infrasonic sound. Inaudible sounds with a frequency more than 20,000 Hz are known as ultrasonic sounds. Bats produce ultrasonic sounds. So we have understood the working of the human ear. Now let's understand the speed of sound. The speed of sound in air is 332 meter per second, and it can travel fastest in solids at a speed of about 5,000 meter per second and in liquids at about 1,500 meters per second. Children, just like light, sound is also reflected and absorbed. And reflection of sound is a widespread phenomena. Why do you think echo takes place in hilly areas? When you're standing atop a cliff, why do you hear your sound again? You hear your sound because that is reflection of sound. Now, right now, I am recording this lecture in a soundproof room. Here in this room, there are soundproof materials fixed to the wall so that when I am talking, the sound is not reflected and you do not hear an echo in the lecture. So, this is how absorption of sound takes place. Now, let's understand about musical sound and noise. So, there are various musical instruments. How? Let us understand. Pleasant sounds are produced by playing musical instruments: guitar, veena, and sitar. A string instrument in which music is produced by vibrating a string. The hollow air chambers in them help to increase the loudness of the sound produced. Flute, bugle, shehnai are wind instruments. On blowing air into them, the column of the air inside vibrates, producing a note. Drum, tabla, and mridangam are percussion instruments in which a vibrating skin or membrane produces a musical sound. Harmonium and mouth organ are reed instruments that contain metal reeds which produce sound when air is blown through them. Manjira, tarang, ghatam are musical instruments that are simply beaten or struck to produce sound. So children, these were some musical instruments which produce good sound, pleasant sound. Now, what is noise? So any sound that is unpleasant, that you want to stop, becomes noise. Honking by the cars, when you hear loud music over loudspeakers, all these are noise. And when this noise increases in the environment, it causes noise pollution. Now, how do you control noise pollution? Let us understand. Making the human settlements away from industries, railway stations, and airports. With the help of proper town planning, the roadsides can be lined up with tree linings, as trees act as a good sound absorbers. Banning the use of loudspeakers near hospitals and educational institutions can help in controlling noise pollution. Using musical instruments and entertainment systems under controlled sound can help to reduce noise pollution. The vehicular traffic should be diverted away from the human settlements. This can be done by constructing ring roads which divert major portion of heavy vehicles to the peripheral regions of a city which has relatively lower population and more vegetation. So children, in this chapter we have learned sound. We have learned how sound is produced, how sound travels, how oscillations are created. We've also understood the concept of noise pollution. So I hope you are thorough with the chapter and are ready to attempt the questions at the back. Thank you for joining us.